Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button. Lecture 5 in the Fundamentals of Mathematics, long division. So recall that division is the opposite of multiplication, much in the same way that subtraction is the opposite of addition. So what exactly is division? Well, let's imagine it with a problem. Let's say that I had $15 and I wanted to distribute it amongst 3 people. So we'll put our 3 people right here on the board. And so the question is, can I divide it evenly amongst these 3 people? If I can, then that tells me that 15 is divisible by 3. So let's test it out. How would we do it? Well, we take our dollars, right? 15 of them, and we give $1 to each person. All right? We've gone from $15 to $12, right? Then I give another $1 to each person. Now we've gone from $12 to $9. Then we give another $1 to each person. Now I've gone from $9 to $6. Give another $1 to each person. I've gone from $6 to $3. And I've got $3 left, which means I can just cover these 3 people. And so how many dollars does each person get? Well, we can count it up. 1, 2, 3, 4, 5. This person in the middle also got 5 because remember how I distributed them. I distributed them one at a time to each, yes? So that's 5 times 3 is 15. So the multiplication fact, 5 times 3 equals 15, is true, which means that 15 divided by 3 is 5. So you can see the relationship here between the different parts of the multiplication and the division problem. These two are still lined up, and these two kind of switches places. You see that? So there are names for each part of an addition problem, a subtraction problem, a multiplication problem, and a division problem. But it turns out that the names of these different parts don't really matter so much for multiplication and addition and subtraction. The names are kind of obscure, things like subtrahend and multiplicand, and they're not that useful. But the names of the parts of a division problem actually are pretty useful. And so I'm going to go ahead and cite them here. This first part, in 15 divided by 3 equals 5, is called the dividend. This part after the division symbol is called the divisor. And this last part here at the end, what we'd call the answer, right, is called the quotient. And so we'll make reference to these parts of a division problem as we go through today's lesson learning about how to do long division. We will rely quite heavily on our multiplication facts and our division techniques from lesson 3, right? So for example, if I ask what is 60 divided by 5, right, using my division techniques from lesson 3, I would say, well, 6 times 2 is 12, so 60 divided by 5 is 12. Okay? Similarly, 84 divided by 2, well, half of 8 is 4 and half of 2 is 1, so 84 divided by 2 is equal to 42. But let's take a look and see, how do we lay out a long division problem? That's our real task here, right? Because we're going to deal with division problems that are larger than what we can do mentally or what we might have multiplication facts to solve. But let's do a simple one just to get started, one we already know the answer to, this 84 divided by 2. And there are going to be essentially 5 steps that we'll go through in order to do the long division problem after we get it set up. But the first thing we have to do is set it up. And so it begins by drawing a special symbol. It's basically a parenthesis with a little bar on the top of it like this. Okay? Now inside this strange symbol, we're going to put the dividend, 84. And then right in front of the parenthesis, we're going to put the divisor, 2. So now that we have it set up, we can go with the first step to doing a long division problem, which is to work from left to right. And that's different than the other way. Every time we did, pen and paper math before, we always went right to left. The only time we went left to right is during mental math, right? So this time it's different. We're going left to right. And we'll start with the first digit in the dividend. Now, instead of asking, well, how many 2's go into 84, or what is 84 divided by 2, we can break it up into little pieces, one digit at a time. So we can ask, how many 2's go into 8, or what is 8 divided by 2? And so that's the current problem that we're working on. What is 8 divided by 2? And so we have to think of a multiplication fact, something times 2 equaling 8. And can we think of anything?
42.
No. Something times 2 is equal to 8. What thing would that be? 4, exactly. So the relevant multiplication fact here is 4 times 2 is equal to 8. So what we do is we place above the 8, 4. 4, and then, now this is the next step. After we've aligned our answer in the answer section, this is the quotient area, right? So 4 is the first digit of our quotient. Now we take this quotient times the divisor, and we write the answer underneath the 8. So 4 times 2 is 8. It's just kind of a duplication of this multiplication fact we use to crack this part of the problem, okay? And then we put a little bar under it like this, and we put a subtraction symbol right here. And the reason we do that is because we need to take the difference between this number and the dividend and this product that we got by multiplying the divisor times our partial quotient, okay? So 8 minus 8 is 0. We write the 0, and we drop down the next digit. Okay? Now that 0 doesn't make any difference. So if we didn't want to write it, we wouldn't have to, because 8 minus 8 is 0. We could have just written it like this and dropped down the next digit. That, however, is a very important step, to drop down this next digit, because that is the new piece of the dividend that we're going to work with, okay? And so now we're going to try and divide 2 into 4. And so the problem that we're working on now is 4 divided by 2. And so we need to think of a multiplication fact, something we can multiply by 2 to get 4. Anyone have any clues what that is?
2.
2. Yes, 2 times 2 is 4. So we write a 2 up above the 4. 2 times 2 is 4. And we take the difference, and we get 0. And since we've come to the end of the digits in the dividend, and we have a 0 remainder here, we know we're done with this problem. And so this is how we do long division. Of course, we can check our answer, can't we? Because we know how to multiply. So we should always check our answer. And what would we have to do to check that answer? We would have to take our quotient, 42, multiply it times the divisor that we had, 2, and see if we get 84 back. Well, 2 times 2 is 4, and 2 times 4 is 8, and sure enough, we get the answer back. And so everything looks good here.
Okay.
Now we're ready to try one at home. So try 369 divided by 3. Pause the video, come back when you have your answer. Okay, so first we just have to set this thing up. So we'll write our parenthesis, and we'll put our little bar over like this. We'll write the dividend, 369, very neatly underneath here. And then we'll put the divisor, 3, right there. And we begin our problem working left to right with this first 3. So I don't have to worry about how many 3's go into 36 or how many 3's go into 369. At this point, I just have to worry about how many 3's go into 3. And that one's a pretty easy one, right? Because 1 times 3 is 3. So we know what that answer is. 1 times 3 is 3. We write the product underneath the dividend, and we subtract. We take the difference in the 2. And 3 minus 3 is 0. And I'm not going to write the 0, but you could. And we drop down the next digit, the 6. You don't have to write the arrow, by the way, but I'm just doing it to illustrate. And now this is our new working digit, right? So how many 3's go into 6? Well, 2 times 3 is 6. So 2. So I write the 2 above the 6 in the answer section. 2 times 3 is 6. I write that underneath here. And I subtract the 2. Again, a remainder of 0. Don't have to write it. Drop down the next digit. 9. So now I'm working with the partial dividend, 9. How many 3's go into 9? Well, 3 times 3 is 9, so it must be 3. So I write a 3 above the 9 in the answer section. 3 times 3 is 9, and I take the difference, getting a remainder of 0. And so I get the answer 123. Now, of course, we can check that answer using multiplication. 123 times 3. 3 times 3 is 9. 3 times 2 is 6. And 3 times 1 is 3. And so 123 times 3 is 369. And everything checks out just right. Okay? Now, so far, all the problems that we've worked have relied upon single-digit multiplication facts, but that won't always be the case. So let's make the problem a little more complicated. let's try 432 divided by 6. So let's go ahead and set this up. And we'll begin. The first thing we notice is that 6 does not go into 4, does it? Now you could write a 0 up here in the answer section. That's fine. 0 times 6 is 0. 4 minus 0 is 4. And then we would drop down the next digit, the 3. But you can see it wouldn't have mattered if we didn't write that 0 down. We could have just moved on to the next section in the answer section up here, right above the 3, and started there and asked how many 6s go into 43. It would work out the same. And I think that's actually a preferable way to do it. It makes the work a little less messy. Since we can't get any 6s into 4, we have to add the next digit. And so we'll consider how many 6s go into 43. And so this one we can, go through our multiplication facts, and we'll see that 6 times 6 is 36, but 6 times 7 is 42. Okay? Nothing is actually going to, we're not going to get anything that actually equals 43. So, but we can get close, right? Because 7 times 6 is 42. So we'll write a 7 above the 3, not above the 4, because it didn't divide into 4, it divided into 43, right? And then 7 times 6 is 42. We'll take the difference between this portion of the dividend and our product, 42, to get 43 minus 42 is just 1. We'll drop down the next digit, and now we have a working dividend of 12, okay? So we ask, well, how many 6s go into 12? Well, 2 times 6 is 12. So we'll write a 2 above this 2 in the answer section. 2 times 6 is 12. We take the difference, we get 0, and so we get an answer of 72. We can check our answer by multiplying 72 times 6, and hopefully we will get back the answer 432. 6 times 2 is 12, carry the 1. 7 times 6 is 42, plus 1 more is 43, and there we have it, 432. Now let me give you one to try. 152 divided by 8. So go ahead and pause the video, come back when you get that one complete. Okay, let's set this up. Writing 152 underneath our little division bar, putting 8, the divisor, to the left of the parenthesis. Starting with the firstmost digit, well, 8 will not go into 1. So we'll move on and consider the first 2 digits of the dividend. Can we get 8 into 15? Well, only one time, right? 8 times 2 is 16, but this is 15, so we can't go over this number, right? So we need to just go in one time. So 1 times 8 is 8, and we have to take a difference now. What is 15 minus 8? Practicing our subtraction.
7.
7. So we write the 7 down and we drop down the next digit, 2. Now the problem that we are posed with is how many 8s go into 72? Can anyone answer that question? Something times 8 equals 72.
8 times 9.
9 times 8 is 72. That's correct. 9 times 8 is 72. So we write a 9 here. 9 times 8 is 72. The difference is 0. We're done. We can check our answer. 19 times 8. 8 times 9, or 9 times 8, is 72. Write down the 2, carry the 7. 8 times 1 is 8, plus 7 is 15, and we get 152. Good. Now, so far, everything has worked out nice where all of the remainders that we had inside of our long division problems were always 0, right? Everything was dividing evenly. Maybe not at the beginning, but by the end it was dividing evenly. What if we were to try and distribute, $16 amongst 3 people? Let's have a look at that. Here are our 3 people again. There's 3, there's 6, there's 9, there's 12, there's 15, but I got one more dollar to give out. But I have 3 people to split it amongst, huh? So apparently I cannot evenly divide 16 by 3. There's a remainder of 1. There's 1 left over. So that's what we're going to explore now, is this idea of a remainder. But first, I want to point out that the remainder can never be more than or equal to the divisor. So if you get a remainder that's bigger than the divisor, then you've done something wrong. And I'll show you how that would work out. Let's take a look at this problem. Let's do 186 divided by 2. And I'm going to intentionally make a mistake here. So we go into this problem and we say, all right, well, how many 2's go into 1? Well, none. So let's consider the first 2 digits. And we know that 9 times 2 is 18. But let's pretend that we made a mistake and we thought 8 times 2 was as much as we could get. So we take 8 times 2 is 16. We take a difference here. 18 minus 16 is 2. Oh, now I know I've made a mistake because my remainder is the same size as my divisor. Okay? And that is not allowed. So I know that I need to go back and check my work because I've made a mistake. So I look at it, I'm like, well, okay, if I have a remainder of 2, that means I can get I can take 2 more out of 18, right? So I can go back, I can fix this. Aha, not 8, but 9 times 2 is 18. Leaving me a remainder of 0, drop down to 6. How many 2's go into 6? Well, that would be 3. 3 times 2 is 6. And 6 minus 6 is 0, and I'm all done. But in the end, this problem came out to be evenly divisible. We just had this issue with making a mistake with our partial remainder whilst we were working the problem, right? Let's take a look at a problem where we actually have a remainder when all is said and done. I want to do 125 divided by 9. Okay? 125. We're going to divide 9 into it. Well, how many 9's go into 1? 0, of course. So we'll move on to how many 9's go into 12. Well, there we can only get 1. 1 times 9 is 9. And 12 minus 9 is? 3. Write down the 3, drop down the next digit, 5. All right, how many 9's go into 35? So we have to think back at our multiplication facts. We know that 9 times 3, what is 9 times 3? Is that going to be big enough? That's 27. What is 9 times 4?
36.
36. Oh, 36 is too big. It won't go, right? You see that?
Yep.
So we're going to have to stick with 9 times 3, aren't we? So we write down 3. 9 times 3 is 27. 35 minus 27 is?
8.
8. And there are no more digits to drop down. So what do I do? Well, I can't do anything. I'm out of digits in the dividend, and so I'm stuck right here with this 8 at the bottom instead of a 0 as we've always had before. But one thing you can do is you can write it like this. You can write 13 with an R for remainder and then an 8. Now what does that mean, right? How can we check our work to see if we got this right? Because if we multiply 13 times 9, what do we get? Obviously we're not going to get 125, right? Otherwise we would have made a mistake in our division here. But let's see what we get. 9 times 3 is 27. Carry the 2. 9 times 1 is 9. Plus 2 is 11. So we get 117. Well, that's not 125, is it? But observe, if I simply add 8 to 117, what do I get? Well, if I added 10 to 117, I'd get 127. But that's 2 too many, so I got to go back to 125. Yes. So 125 is actually equal to not 13 times 9, but 13 times 9 plus 8. You see? So we have to add the remainder on after we've taken the quotient times the divisor, right? And that will give us back our original dividend. Okay?
Okay.
Let me let you try one at home. I'd like you to perform 290 divided by 7. Go ahead and pause the video and try that now. Okay. Let's set this up. 290. Our divisor is 7. 7 won't go into 2, so we have to consider how many 7's go into 29. And we may recall from our multiplication facts that 7 times 4, or 4 times 7 rather, is equal to 28. And that gets us pretty close. So let's go ahead and try that. We'll put the 4 here. 4 times 7, 28. You get lots of practice with your multiplication here, right? 29 minus 28 is obviously just 1. 1 is less than 7, so we're good with our partial remainder. We need to drop down the next digit, though, and we get a 10. Well, how many 7's go into 10? Well, just 1, right? So we write the 1 above the 0. 1 times 7 is 7. 10 minus 7 is 3. So we have a remainder of 3. And if we were to multiply 41 times 7 and add 3 to it, we should get back 290, but I'll let you do that on your own. Now I want to show you something that may confuse some people and throw them off when doing long division, and that's when they encounter zeros in the dividend. So let's look at a problem like, let's do 4,203 divided by 9. Well, It's a little bit of a longer problem than we've considered, but that's not really a big deal because we're going to do this one digit at a time, right? So it's okay. 9 will not go into 4, but how about 9 going into 42? Can we get 9 into 42? Well, 9 times 5 is 45. That's a bit much, so we'll have to go with 9 times 4, right? So 4 times 9 is 36, and 42 minus 36 is 6. Drop down the next digit. So it's a 0. There's no problem with just dropping it down, though, right? Because it just means that we're going to divide 9 into 60 now, right? So how many 9s can we get into 60? Well, 9 times 6 would be 54. 9 times 7 would be 63, so we'll have to go with 6, right? 6 times 9, 54. 60 minus 54 is 6. 6 is less than 9, so our remainder looks good. Drop down the next digit, that's a 3. And now we have 9 into 63, and we know that's just 7. 7 times 9 is 63. 7 times 9 is 63. And we have a remainder of 0. And we're done. So let me give you one to try. I think I may throw you off with this one. 4,004 divided by 4. Let's go ahead and try that one now. Pause the video and come back when you're done. Okay, let's set this one up. 4,004 divided by 4. Well, the multiplication facts here couldn't be easier, right? How many 4s go into 4? Well, that would just be 1, right? Because 1 times 4 is 4. Leaving a remainder of 0, drop down the next digit. Now here's where you might have gotten confused, huh? 0. How many 4s go into 0? Something times 4 equals 0. Can anyone guess what that is?
0.
0. 0 times 4 is 0. So we put a 0 right here. 0 times 4 is 0. Now, do I really have to do this? 0 minus 0 is 0. Drop down the next digit. I should if I want to, make sure that everything is looking good. But I could have just maybe skipped ahead if I know where this is going. But let's just plot on, huh? Now I've got 4 into 0 again. What do I have to multiply 4 by to get 0? Well, again, it's just 0. 0 times 4 is 0. 0 minus 0 is 0. Drop down the next digit. Now I have 4. How many 4s go into 4? Well, just 1. And 1 times 4 is 4. 4 minus 4 is 0. So I divided 4 evenly into 4,004. Now, you've probably noticed that so far we've only been doing one-digit divisors, right? Now, what about two-digit divisors? Well, you can do that too. If your multiplication facts are good, I think I mentioned in the third video that if you're going to work on multiplication facts, going all the way up to your multiplication facts up to 20 would be a good idea. But realistically, most people probably know them up to 10. Some people might know them up to 12, others 15. But that's fine, because if you look at the techniques that we used for quick mental multiplication in Lecture 3, then you'll be able to construct partial tables on the fly as you work these problems. But let's just take a look at one. Let's consider 546 divided by 13. Okay, 13 does not look like a friendly number to work with, right? But let's move ahead with it and see what we get. So we'll set this guy up here, putting our dividend under the division bar and our divisor to the left of the parenthesis. Now, we need some place to work with. So what I advise doing is either in your head or quickly on the side, construct a little mini multiplication table with just a few multipliers. I want you to do 13 times 2, 13 times 4, and maybe up to even 13 times 5. And we'll know as we work the problem if we need anything bigger than this, okay? So 13 times 2, that's just a doubling problem. The double of 13 is 26, right? Because the double of 1 is 2, the double of 3 is 6. Then we got to do 13 times 4. We just have to double what we just doubled, right? So the double of 26, we double the 2 to get 4, but we have a big neighbor, so it becomes 5, and then we double the 6 to get 2. And so 52. And then 13 times 5, well, that's just half of 130. Well, half of 120 is 60, so half of 130 is going to be 65. And so now we've got a few multiplication facts at our disposal, and we can see that the first thing we're going to consider, 13 into 54, right? Well, we can get pretty close with 13 times 4, right? So our first entry in the quotient section here is a 4. Put it above this 4 because we're dividing 13 into 54 and not into 5. 4 times 13, we've got that right here on the side, 52. 54 minus 52 is 2. 2 is smaller than 13, so we got past that mental check. We drop down the next digit. We got a 6. Well, this one, we see it's right there in our multiplication table. 26 is just 13 times 2. So we write the 2 above the 6. 2 times 13 is 26. We take the difference, we get a 0, and we're done. Now, with a problem like this, we should probably check the math, right? So we should write this out. 42 times 13, and we should do the long multiplication. 3 times 2 is 6. 3 times 4 is 12. Don't forget to add the 0 because we're multiplying tens now. 110 times 2, that's going to be 20, or we just write a 2 here. And then 1 times 4 is 4. Add these guys up. That's 6, 4, and 5. 546, which was the dividend that we had. So it looks like we did this correctly, okay?
Wouldn't it be nice if you could just look at an arithmetic problem and know the answer? Wouldn't it be nice if it was as easy as reading off the digits? Wouldn't it be nice if large numbers were no more difficult than small numbers? They just take a little longer to rattle off the answer. This is exactly what the method in digit-by-digit arithmetic achieves. For example, you can multiply by 5 by simply reading off half of each digit from left to right and adding on a 0 when you're done. For 2 times 5, you would simply say 10 because half of 20 is 10. Digit-by-digit arithmetic, fast math to minimize working memory strain.
Now, let me give you one to try to close this lesson out. I want you to try 625 divided by 25. Pause the video and come back when you get the answer. Okay, it's not as bad as it looks. We'll set the problem up in the usual way with our division bar, writing the dividend 625 underneath, and the divisor 25 to the left of the parenthesis. And we'll want to construct a little mini multiplication table, just like before. So 25 times 2, double of 25. If you think of quarters, it's pretty easy, right? 2 quarters is 50 cents. So the double of 25, 2 times 25 is 50. We can double 50 quite easily. That's just 100. So 4 times 25 is 100. And then 5 times 25, well, that's just going to be half of 250, which is 125. And that's probably good enough to get started because the first thing we're going to consider is how many 25s go into 62. And we can see that 2 is about what we're going to fit in there, right? So write a 2 right here above this 2. 2 times 25 is 50. 62 minus 50, 12. 12. Drop down the next digit, 5. So that's an interesting spot to be in, right? Because now we've got another 3-digit number. But you're going to encounter this. But we see that we've already got that in our multiplication table. 25 times 5 is 125. So we write down 5 here. 5 times 25, 125. And 125 minus 125 is 0. And so we are done. Okay, so at that point, we've covered all the basics of arithmetic involving whole numbers. We've covered addition and subtraction and multiplication and division. And so the next thing for us to tackle is factorizations. And so that's what we'll tackle in the next lesson. See you then.